Hmm. So we are live. Just hold on a minute. I'll just check that everything is fine or not. Okay. Okay. So welcome back. It's been a long day. It's been a long time actually since I just continued. So it will not happen again until Raul comes to home. So we just continue where we stopped from where we stopped. Before that, we will just revise previous lecture things. Okay, so just hold on. I'm just finding the right page. And the last chapter we just revised is components of OS, and we already just discussed that there is only two components of operating system. First is user space, and second is kernel. Okay, we just discussed that. Now the question is, what is a user space and what is a kernel space? User space is a environment in which user can run his application, and kernel is the real core or heart of the operating system. You can say um, all the hardware management work is done by the kernel. Okay, okay, now you understand what is the kernel and what is the user space. Now let's say if this is your kernel. Okay, sorry, let's say this is your user space and this is your kernel and this is your hardware. So actual interaction between hardware and kernel is happening by using kernel. So who is actually dealing with hardware? Not complete operating system. The part of the operating system that is dealing with the kernel, dealing with the hardware is the kernel. That's good. That looks good. Now now let's just discuss what are the functions of kernel. First, process management. Which process in which state is going on and what's going on with the process. Let's say the PCB state of process, and let's say the current state of process. Is process is waiting, or it's a zombie process or other type of process. Okay. Second, file management. All the file management work can be done with the kernel. Third, input output management, IO management. Let's say you just plugged in new pen drive to your system, or let's say you just plugged in a new CD to your system. That all just handled by your kernel. Fourth, RAM management. It's also done by kernel. Which RAM part is used by which program? All this is just managed by your kernel. Looks good. Okay, looks good. Now we just discussed three types of kernel. We just discussed three main types of kernel. Okay, the first type is monolithic kernel. Let me just yeah, this looks okay. The first type of kernel is monolithic kernel. These types of kernel is used by Linux or Unix operating system, in which uh, all the let's say hardware management is done by the kernel. So okay, now what will the gain of these kernel? The work is so fast because everything is handled by kernel, but it's not let's say I can say reliable. Reason for that is, let's say somehow your kernel is down, or somehow there is, let's say a problem called kernel panic, or anything something happens with kernel, then your whole system is down. You can't do anything with user space. Okay, it's less reliable, but it's more fast because uh, because the shifting between user space to kernel space is very time consuming and CPU consuming process. That's why we just don't want to do that. Second thing is, okay, okay, um, high performance communication is fast, but the problem is one of problem is the kernel is very bulky in size because all the system management, all the hardware management code is in the kernel. Looks good, looks good. Now let discuss the second type of kernel, that is sorry, the second type of kernel, that is microkernel. What just happened in microkernel? All the operating system management work is in the many operating system, when many hardware work is in the, let's say, in user space, and many or some hardware work or some hardware work definitions in the kernel. So let's say file management and process management is in the user space, and let's say RAM management or IO management is in the kernel. Now let's say it's now your kernel is not become bulky. My kernel don't become bulky, but the interaction or the transition between user space to kernel space is very costly. So there is a little headache in our brain or in the CPU to switch between them. Let's say you are doing a work in, let's say, in user space, and somehow he let's say your process is working on files, so you are in user space, and let's say he just want to access, let's say, RAM, or want to access some data from the RAM. Then he switch to kernel mode and the user mode, kernel mode, and this switching is very costly. Okay, I hope you understand that. Now the third type of kernel is the hybrid kernel. It's the mixture of monolithic kernel and the microkernel. What we just did is file management work is in the user space and the other work is in kernel space. So now kernel doesn't become too bulky, but okay, it's a combined approach. Now the headache between interchange between user space and kernel space is now reduced, because some of let's say kernel work is in now user space, and it's a combined approach, and Windows or Mac uses this approach. Okay, now there's a question, what is how to let's say communicate between user space and kernel space. With we will do communication between user space to kernel space is with IPC, inter process communication. Two process execute independently have same memory. Now let me share you my screen. Hope it's visible to you. Okay, now what we'll do is nothing more. We start new lecture, new lesson in system calls. Now before move on to the chapter, let's discuss what is a system call. Okay, okay, let's say this is your user space and this is your kernel. Okay, and let's say you want to switch from user space to kernel. Then how you can do that? You can do this by a system call or throwing an interruption between this. How you will do that? Quite easy. Just do one thing, that is uh, simply call a system. Let's say, how do apps interact with kernels using system calls? We will discuss them very deeply. Let's say you have let's say you have a command mkdir lks the folder name. Okay, remember that lks the folder name. Or okay, what will this command do? Nothing more, just create a folder. mkdir independently call kernel and ask the file management department. And what will this command do is just call the file management department of kernel and say please create a new folder for me, and kernel will do that and throw a response to the system call and say I did it for you. mkdir is just wrapper of actual system calls. Okay, we if you don't know actual systems call, let's say actual system calls is a fork or create new folder, but we we are not doing that. Or we are these things are abstracted to us for us. मैं चूतिया हूँ, पता है तुम्हें. mkdir interacts with kernel system calls, creating a process. User executes a process, user space, get systems call, execute systems call to create a process in kernel, return to user space. Transactions, as we already told you that transactions from user space to kernel space done by software interrupts. Okay, I hope you understand that. Now your question is, okay sir, you're saying the system calls are some functions implemented in C. Okay, system calls is nothing but some functions implemented in C. Hold on a second. Okay, everything is fine. I hope it's visible to you. Now let's move forward. So system calls are nothing but some let's say functions or created by OS, created in OS. I will A system call is a mechanism using a user program can request a service. A system call is a mechanism. A system calls is a mechanism using a program can request a service from kernel for which it does not have permission to perform. User program doesn't have permission to, let's say, any file management work or RAM management work. We never provide this permission to user program. All these permissions are in kernel. So user program will request these things to the kernel, that say, hey kernel, just do it for me, just create this folder for me, and kernel will do this for us. Okay, a system call is a mechanism. Okay, user program can request a service from kernel which does not have permission to perform. Okay, so what user program will do, it will just call, it will just run a function already implemented in the operating system kernel, that please make a folder for me, or make a directory for me, or make a file for me, or others. System calls are only way through a process can into kernel mode and user mode. Okay, the program is running in, let's say, started in user mode and saying please create a, okay, as you can see we have two modes. First is user mode and second is kernel mode. And in user mode our application, let's say this is user space, this is kernel space, so in this space our application is running. Okay, and in this space all the kernel or hardware work is working. So glibc, what you are saying, just thinking what is this, Yogesh? So don't take tension. C implement, it's nothing but C implemented library to call system call interface. It's you see implemented library to call system call interface. Now when you call system call interface, you are switched to kernel, and now your kernel have some work to do, and it will do to the hardware. Now we know what is a system call. System call is nothing but C implemented functions that helps us to use, that helps user program to interact with the kernel. Again, a system call is a mechanism using user program can request a service from kernel which does not have permission to perform. Again, let me tell you, system call is nothing but an mechanism using which user program can request some features from kernel, because user program doesn't have permission to do that, do not have permission to perform operations like accessing IO devices and communication with other programs. Kernel will do that to this through system calls. Now there are multiple types of system calls. We will discuss them one by one. After that we'll move forward. First type of system call is process control. Let's say you want to control